Astronomy Unit. We're going to be reading the STEM Scopedia. Reflect. Have you ever had a chance to look through a telescope? The night sky is full of celestial wonders. You can see planets, moons, gas cloud called nebulae, and the distant galaxies beyond our Milky Way. With your own eyes, you can often see several of the closest planets, such as Mercury, Venus, Mars, Jupiter, and Saturn. Uranus and Neptune require a telescope to bring them into view. Our solar system. Our solar system includes our sun and planets, moons, asteroids, comets, and other frozen worlds that orbit the sun. The solar system is one of the arms of the spiral Milky Way galaxy. The sun, our daytime star, is one of billions of stars that inhabit this spiral galaxy. There are also billions of other galaxies that populate our universe. Here you can see this is the Milky Way galaxy. It's a spiral. Our solar system is located about right here. Our sun. From our vantage point on Earth, the sun appears quite big and bright because it is our closest star. Other stars are vast distances from Earth and appear only as pinpoints of light. You would need a telescope to see the Milky Way and beyond to other galaxies. Compared to other stars, the sun is actually a medium-sized star with an average temperature. There are other stars quite larger than the sun. Compared to the planets in our solar system, however, the sun is enormous. You can see at the picture here on the right, the sun is huge, and look how small Jupiter and Saturn are, and then all the other little tiny planets right there. The order of the major planets from the sun is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Pluto was reclassified as a dwarf planet along with Ceres, Eris, and Makemake. Let's reflect. The solar system is made of special categories of celestial objects or objects in space. Sun versus stars. Although you can see stars in the night sky, they are not part of our solar system. Our only star is the sun. The stars you see as familiar constellations are far beyond the edge of our solar system and are part of our Milky Way galaxy. To see other galaxies in the universe, you will need a telescope, though in November you can see the Andromeda galaxy without any tools. Satellites. Moons are called satellites because they are objects that orbit another object, such as a planet. Scientists have found 173 moons in our solar system, most of which orbit the huge gas giant planets. Rocky planets versus gas giants. Mercury, Venus, Earth, and Mars are spheres made primarily of rock, but not all objects in space are made of the same material. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants. The gas giants also have rings. Although Saturn has the biggest ring system, the other gas giants also have ring systems. Dwarf planets. Dwarf planets like Pluto and Eris are made of rock and/or ice and orbit a star like our sun. Beyond Neptune lies the Kuiper Belt, with thousands of frozen planetoids similar to Pluto. The largest body in the asteroid belt, Ceres, is also considered to be a dwarf planet due to its size and round shape. Asteroids. Not all bodies in space are round. Asteroids are rocky and irregular shaped bodies that orbit the sun and are too small to be planets. Most asteroids can be found in an area called the asteroid belt, which lies between Mars and Jupiter. Other asteroids can be found orbiting the sun near Jupiter, while others orbit the sun closer to Earth. Meteoroids. These smaller rocky bodies often crash into planets and moons as meteorites. Other smaller pieces burn up in the atmosphere as meteor flashes. Comets. Leftover debris from the formation of the solar system orbits beyond the edge of our solar system in the deep freeze of space. Many comets orbit the sun in orbits shaped like elongated, stretched out circles, or ellipses. As they approach the sun, their frozen gases warm up and become long tails of gas and dust that drag behind them. Here you can see our solar system, the dwarf planets up close, a meteorite, asteroid, and a comet. Planets. In our solar system, we have two basic groups of planets. The inner planets, Mercury, Venus, Mars, and Earth, are small, are rocky, and have few or no moons. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants with many moons and ring systems, although not all the rings are visible from Earth. Here you can see their sizes, and they are to scale. Mercury is the closest planet to the Sun and the smallest planet. The cratered surface of Mercury looks like the Moon. Venus is the second planet from the Sun. Close to Earth's size, it is the hottest planet and has a thick carbon dioxide atmosphere. Earth is the third planet from the Sun and the only planet with life and water in 3 phases. That means solid, liquid, and gas. It is covered 3/4 in water and has 1 moon. Mars is the fourth planet from the Sun. The red planet has ancient water. It has the largest volcano in our solar system and has 2 moons. Jupiter is the fifth planet from the Sun. This gas giant is the biggest planet and also has the most moons, 67 and counting. Saturn is the sixth planet from the Sun. This gas giant has the largest ring system and 62 moons. Uranus is the seventh planet from the Sun. This gas giant goes around the Sun on its side. It has a vertical ring system and 67 moons. Neptune is the eighth planet from the Sun. This gas giant has the fastest winds. Its blue color reminds you of the sea. It has 14 moons. Reflect. Let's look at the image of the crescent moon hanging over the eastern morning sky. Can you see the bright light to the upper left side of the moon? It is brighter than any other object in the sky beside the moon. Do you think it's a star? Ancient Greeks did. They called it the morning star. What they were looking at is not a star, but the planet Venus. We were able to see this just a few weeks ago. Star patterns are called constellations. Stars are enormous balls of hot, dense gas that give off their own light. Stars are very far away, so even though they are huge, they appear as tiny points of twinkling light. Stars twinkle because tiny movements in the atmosphere refract or bend the points of light every millisecond. Stars do not appear evenly spread throughout the sky, but are scattered like connect-the-dot pictures. Ancient people looked at the stars and named these patterns for gods, animals, and objects. In the winter sky, the hourglass figure with 3 stars in his belt and 1 arm up was named by the Greeks in honor of Orion the hunter. These fixed patterns are called constellations and appear to move across the sky as Earth rotates. Planets move against the backdrop of stars. Planets do not give off their own light, they reflect light from the sun. Planets do not twinkle as much as stars because they are closer than the stars. Planets look like small disks of colored light. However, planets did not look like stars to ancient people. Sky watchers from long ago noticed that some lights seemed to wander among the background of constellation patterns. They did not know they were planets in our solar system. The ancient Greek name for planet means wandering star, and the Greeks worshiped the planets as gods. Here you can see this is the order of our solar system, and this is the constellation Leo. It has a star named Regulus, and here is Mars, which is very close to Regulus. It says Mars, like all planets, moves around the sun. When Mars is on the same side of the sun as Earth, it appears to move slowly against the backdrop of constellations. The image on the right shows Mars below the bright star Regulus in the constellation Leo the Lion. Mars will take 5 days to move up at an angle to the left and beyond Regulus. So Mars will move this way. Stars look like they are all the same distance from us. Our brains can detect changes in distance only if we have comparison points. For example, if people walk away from us, they get smaller as they move against the surrounding buildings. With the blackness of space, however, it's hard to see what is close or what is far. Imagine you see 3 cars with their lights on in a parking lot at night. Without any streetlights for comparison, the cars appear to be in a straight line, when they are in fact parked at different distances from you. We're going to skip this model right now. Reflect. Constellations move. When Earth rotates, it gives the illusion that stars move across the night sky. From Earth, stars appear in patterns called constellations, which move across the sky from east to west. The Big Dipper constellation appears to stand on its handle early in the evening. As Earth continues to rotate, the Big Dipper appears to shift its position from east to west in a big arc. So look at this picture here. East to west, you would be facing north. This right here is the Big Dipper. This is at 9 p.m. If you went outside at midnight, the Dipper is turned upside down and it's moving at an arc, and at 3 a.m. it is about to set and it's going to be upside down on its pan. Constellations also change with the season. As Earth moves in an orbit around the Sun, it is pointed at night to a different location in space with each season. Imagine you are Earth walking around the edge of your living room. Each wall is a different season. As you pass each wall, you notice different things hanging on that wall, just like you see different constellations each season. So here, this is Earth's orbit. Okay, they're showing winter here, spring over here, summer there. Obviously, they went to squeeze it together so you could see it in one picture. Here you can see Orion in the winter, but as we move to spring, our nighttime faces this section of space and you can see Leo. As we move to summer, you can see Scorpius, because during the daytime we would be facing the sun. Telescopes changes everything. Prior to the 17th century, that means before the 1600s, all observations were made with the naked eye. Humans could see only the sun, moon, stars, and 5 planets, Mercury, Venus, Mars, Saturn, and Jupiter, in the sky. The universe was very small to ancient observers. In 1609, a Dutch lens maker, Hans Lippershey, invented a telescope to observe ships. Among other things, telescopes gather light from distant objects and magnify them. In 1610, Italian astronomer Galileo Galilei improved the telescope and turned it toward the sky. What he discovered forever changed our view of the universe. Astronomy is important. We have used telescopes, compasses, and star charts to find other planets and moons in our solar system and galaxies beyond our own. Among many other things, modern society benefits from these spin-offs of astronomy technology. Telescopes led to better navigation. Infrared telescopes led to remote controls and precise weather satellites. X-ray telescopes led to airport scanning devices. Astronomical satellites led to GPS satellites, and so on. Due to astronomy, our world will never be the same.